Welcome back. Now in this particular module, we are going to discuss a concept which is called as radicals. Now understand what radicals exactly are. Let's begin. The charged particles over here, one must understand, are called as ions. A negatively charged ion is called as an anion, as a positively charged ion is called as a cation. I'll repeat, a negatively charged ion is called as an anion and a positively charged ion is called as a cation. In a similar manner, one must understand that therefore we say compounds with ionic bonds are going to have a total of two constituents. Any ionic compound will have a positively charged ion, which was the cation, and a negatively charged ion, which is called as an anion. Okay, now we have to discuss a concept which is called as simple and composite radicals. What are simple radicals? Monoatomic radicals are called as simple radicals. So if in a radical which has a charge, you have a single atom, if it's monoatomic, it is going to be a simple radical. What are the examples? Na with a charge of 1 plus, Cu with a charge of 1 plus, Cl 1 minus, Ag 1 plus, Mg 2 plus, Fe 2 plus, Br 1 minus. All of them have a single atom, all of them have a charge, all of them are considered to be simple radicals because they are monoatomic in nature. On to the other hand, when a radical is a group of atoms carrying a charge, it is called as a composite radical. Have a look over here. Examples are sulfate, SO4 2 minus, ammonium, NH4 1 plus, chlorate, ClO3 1 minus, nitrate, NO3 1 minus. All of them have multiple atoms coming up together. It's a group of atoms that is going to behave as a single unit and it has a charge. Therefore, it's called as a composite radical. Okay. The magnitude of charge on radicals is the valency. So, for example, I have ammonium, NH4 1 plus, the 1 plus is the valency. I have ferrous, Fe2 plus, the 2 plus is the valency. Continuing. Now, I need to give you the ions and radicals in detail. Now, understand. Before I give you this particular concept, there's something that I would really like to tell you. Think about it. Listen to it carefully. You want to be great at chemistry. You need to be great at writing chemical formulas. You need to be great at writing chemical equations. You need to be great at balancing the chemical equations. You will only be able to balance a chemical equation when you write the chemical equation correctly. You'll be able to write a chemical equation correctly when you write the chemical formulas individually correctly. And who will help you write down the chemical formulas? Memorizing each and every ion, memorizing each and every radical which is going to come onto the screen in the next 5 minutes. Understand, to memorize, the best thing is practice. Write the valency chart, write the radical chart at least once a day for as many number of days till and wherein you are able to remember every radical. That's the only way. Practice will make you perfect. Write it once every day, keep on memorizing, and it is volatile. If you stop, all of the knowledge will go away. We don't want that to happen. So write it once every day, continue doing that till the radical chart is perfectly memorized. Get the radical chart, get the chemical formula, get the chemical equation, be perfect at balancing the chemical equation, be a master at chemistry. Correct? Okay. Now, basic radicals over here are the positive radicals. So, every positive radical is a basic radical. Have a look. Who are the monovalent simple radicals? H1 plus hydrogen, Na1 plus sodium, K1 plus potassium, Ag1 plus silver, Cu1 plus cuprous, Hg1 plus mercurous, right? Now, on to the other hand, we have divalent simple radicals, cupric, which is Cu2 plus, Mg2 plus magnesium, Ca2 plus calcium, Ni2 plus nickel, CO2 plus cobalt, Hg2 plus mercuric, Mn2 plus manganese, Fe2 plus ferrous, lower valency, right? Sn2 plus stannous, lower valency, Pt2 plus platinum. That's the last one in this particular list for divalent simple radicals. Okay. Trivalent simple radicals, we have relatively less. Aluminium Al3 plus, Cr3 plus for chromium, Fe3 plus, higher valency of iron, ferric, Au3 plus, higher valency of gold. Tetravalent simple radicals, you have stannic, the higher valency of tin. Now, monovalent composite radicals, we just have a single example for you, ammonium given by the formula NH4 1 plus. Now, that's the total of the positive valencies, the basic radicals, to be written once every day. to get memorized as quickly as possible. And you'll have to do the same for the acidic radicals. So positive radicals were basic, acidic radicals are going to be negative. Let's have a look. Monovalent first, the simple ones. Hydride H1 minus, fluoride F1 minus, chloride Cl1 minus, bromide Br1 minus, iodide I1 minus. Divalent simple radicals, oxide O2 minus, sulfide S2 minus, trivalent simple radicals, nitride N3 minus. Okay, acidic radicals still, but monovalent composite radicals, the ones which are relatively slightly tough because they have the group of atoms together, right? Hydroxide OH1 minus, nitrate NO31 minus, nitrite NO21 minus, bicarbonate HCO31 minus, bisulfate HSO4 1 minus, bisulfite HSO3 1 minus. See the slight amount of difference, you need to get that perfectly done. Permanganate MnO4 1 minus, chlorate ClO3 1 minus, bromate BrO3 1 minus, iodate finally IO3 1 minus. Divalent, who do we have? Carbonate CO3 2 minus, sulfate SO4 2 minus, sulfite SO3 2 minus, chromate CrO4 2 minus, and finally dichromate Cr2O7 2 minus. Okay. Acidic radicals, trivalent, relatively few, phosphate PO4 3 minus, that's it. Now all of the positive radicals, all of the negative radicals, all of the basic radicals, all of the acidic radicals to be written once till you are absolutely perfect. And I've already told you the reason for that. I hope you remember. Okay. Ions and radicals. What are the characteristics of a compound formed by an ionic bond is that its molecule has two parts. So any ionic compound, any ionic bond will have a total of two parts. Positive, which is the cation, negative, which is the anion. There is a cation, basic radical, and there's an anion, acidic radical. These two atoms are always supposed to be oppositely charged. So one is positive, one is negative, one is basic, one is acidic. It's so obvious. And finally, the force of attraction between them constitutes an ionic bond.